Good morning, my YouTube viewers. Crystal here. I'm here this morning to discuss with you the Analytics Twitter Sentiment Analysis program that I put on Jupyter Notebooks. You notice last night I put up a video on the program from sentiment analysis where you were supposed to detect sexist or racist speech. And basically whenever I loaded it up on Analytics Vidhaya, I had like a 54% something. And that's a very low percentage because you want to get the percentage as high as possible. So this morning I was thinking, well, what can I do to increase my percentage? So I looked on the internet and I found that on the logistic regression function, if I added some parameters within the logistics regression function, then I could increase my percentage by 1% to 55% something, which is good. And when you're entering competitions, you need to get your percentages as high as possible. So I did some more search on the internet, and I found that if I use GridSearch, then I can increase my percentages as well. So I went on to the internet, and then I found an algorithm for grid search on, I believe it was the IRIS dataset, and I decided to use that. So what I wanted to do is I just wanted to actually take the program that was written last night and just show you the modifications that I made to it to increase my percentage by another percent. So I increased my accuracy from 54% to 56%, and that's on the Analytics Vidhaya website. So that's good. And whenever you're dealing with competitions and things, you want to get your accuracy as high as possible. So here we go. We input our libraries. We load our files. And here you can see the train file that's got all of these characters in it. We combined the two files. So we appended the text file to the train file. And then what we did was we defined a function to remove patterns from the tweets. So we removed Twitter handles. Then we removed some special characters. Then we tidied the tweets with another internal function called lambda. And we showed the combi file where it's been tidied up. We tidied the tweets up some more. We stemmed the tweets using a Porter stemmer. We had another function where we did some more work to tidy the tweets. And then so basically we had a function where it put all of the words from the tweets into a diagram, so you could see all of the words from the tweets in the diagram. Then we had a function where it put all of the normal words in the tweets, so you could see all the normal words in the tweets in the diagram. Then we had a function where it said you put all of the negative words in a tweet, in a chart. So we had a function where you wanted to extract the hashtags. So you extracted the hashtags from the non-racist tweets. Now we have a diagram of non-racist and sexist tweets, and they have the words there that are in the tweets. Then we have a diagram with racist and sexist tweets. So we have another diagram where you extract some text from the tweets. another formula where you extract text from the tweets. And this is where we actually get into the formula where we predict what the next tweets are going to be based upon the tweets. So here what we had to do was we had to import GridSearchCV from sklearn model selection. And then so we had to split the data. And then we had logistic regression. And what I had originally done is I had originally put some parameters in logistic regression. But I went and tried that again after I used the CV search, and it didn't improve the score. So I took it out. So we set up the penalties, L1 and L2. We set up log space. We set our parameters, and we set a dictionary with C and penalty. So we created our grid search, where CLF is equal to GridSearchCV LREG parameters. CV equals 5, verbose equals 0. That's what we added to the model. So we fit the model. Best model equals CLF fit, X train bow, Y train. And then we printed some things, but then we got a bunch of warnings. A lot of warnings. But we did actually get our best penalty and our best C. So then what we did was we predicted the best model. So you can see the prediction of the best model. So we had to modify the prediction. So we had to modify the prediction equals CLF.predict underscore proba x valid bow. So we had to set up the prediction again. And we got like a close to 53%. And then so this is our submission file that we submitted to Analytics VidHaya. And we've got some other code here where, again, it gave you an output of 47%. And I'm not sure exactly why they did that, because the submission file is before this coding. So I'm not sure exactly why they put the submission file before that coding, but they did. And when I submitted this information, submitted this submission file to Analytics VidHaya, I got 56%, which is a 2% increase over my original 54%. So basically, I just wanted to show my viewers what I did to increase my score by 2%. So I was using GridSearchCV to increase the score by 2%, which it means a lot when you're entering competitions. So that concludes my presentation. If you like my presentation, please like, subscribe, and share. If you like the work I'm doing, I've got my email address, and you can make a donation to PayPal, which it will be very gratefully received. And thank you so much for watching this video, and I look forward to seeing you the next video.